Continuing on, let's get some kind of colors here. We have the following cases show a ramp that consists of a right triangle with legs 2L and L. The ramp is set in each of the configurations with a block of mass either M or 2M. Set at the top of the ramp, the mass slides without friction down the hypotenuse of the triangle. Okay. Rank each of the cases following the criteria. So we're ranking the speed of the block upon reaching the bottom of the ramp, the kinetic energy of the block when we reach the bottom of the ramp, and net force acting on the block as it slides down, the acceleration of the block. Okay, so a lot going on here. Cool. Let's get into it. We're talking about heights. I told you last video, that means conservation of energy. It needs to pop into your brain. Hey, conservation of energy exists. Can we use it? Are we talking about any kind of changing of energies? Yeah, we're talking about a speed. So we definitely have a height, and we definitely have a speed, so that means conservation of energy. Yes, let's do it. So what's happening in all of these instances? Well, we're starting off some height, and then at the end we have some speed. So TMEI equals TMEF. Our gravitational potential energy is all becoming kinetic energy. So mgy equals 1/2 mv squared. V equals square root 2gy. Hopefully, you see that V equals square root 2gy and you say, man, we see that a bunch. Yes, you do see that a bunch. It happens. Same thing happens in physics all throughout this class. Keep doing enough of the practice and it all becomes redundant after a while. So that way you can just look at these and get a feel for what's going to happen. Which by now you already can. You know that C, it's probably going to be the fastest, right? It's definitely going up the highest, it's going to accelerate longer, so it's going to be fastest. These two, we have the same height. So which one's faster? Well, what about the masses? This one has more mass, so is this one going to be faster? No, because what happened to our masses? They canceled out. So mass don't matter. So we get V equals square root 2gy, all that's under the radical. So basically what we're doing is we're just ranking the change in the height. In which case C is first, A is equal to B. C is greater than A equals B. Kinetic energy of the block. Well, we know kinetic energy and velocity are the same thing, right? So can't we just say C is greater than A equals B? Maybe. Let's find out.
Spoiler alert, no.
At the beginning, we start off with gravitational potential energy, and in the end, it becomes kinetic energy. So in this instance, we only need mgy equals k. We don't have to break up k, because we're solving for k. So what happens? Case A, I'm going to bring it down here. A, m is m, so we can, that's basically just 1m times g, okay, times 10, g, and then times, let's keep this, m, g, h, in this case is L. 1L. 1L. 1 times this is going to be equal to k, whatever. Next one, we have 2m times g times L. That's going to equal to kb. And then for C, we have 1m times g times 2L. Are they the same thing? No, it's not C is greater than A equals B. B and C are the same exact thing. 2 times this times this. 2 times 10 times 1 is going to be 20. 1 times 10 times 10 times 2 is going to be 20. 1 times 10 times 1 is going to be 10. So B and C are equal, which is greater than A. Be careful on your greater than, less than. Remember, the alligator eats the big one. Next up, the net force acting. Okay, so what force is acting on this block at the top of the ramp? Right there. Frictionless? Is it frictionless? Is it frictionless? Slides without friction. There it is. Slides without friction. Okay, so the only force acting on it is what? If you said gravity, I am going to reach through the screen and correct you. Alright, so gravity is not acting to drag this thing down the ramp. Instead, what's acting? The parallel component of gravity, which is mg sine theta. Mg sine theta. That's what we're ranking here. Because the only force acting, the stuff that makes it go, equals mg sine theta, equals mass times acceleration. F equals mg sine theta. All we have to do is rank the thetas, right? Or don't we? No, because we have 2m. Let's get to it. So for A, we have 1m times g times sine theta. I thought I timed it right, but I didn't. We don't have theta! Well, where is theta? Let's think about it. Theta's here, and theta's here. Okay, so we have the opposite side. That's given to us, L, or 2L. And we have the hypotenuse. The hypotenuse is the same, it looks like, from the triangle. Slides down the hypotenuse. I believe it's the same. Either way, same or not, we're going to call it h, because it doesn't matter. Okay, so sine theta is just your opposite over your hypotenuse, right? So we're just going to say the opposite, in this case is L, over the hypotenuse, h. Okay, on to B. B is mg sine L over h, right? So these two are going to be the same. No! Be careful. It is 2mg sine L over h. Oh, twice this. So B is definitely going to be greater than A. C is going to be mg sine 2L over h. Now, we're comparing. We don't know what sine of 2L over h is, but because we're comparing, sine is the same, so we can kind of ignore that. So now, what's happening? Well, this is 1 times L, so 1 divided by 1, 2 times 1 times 1 times 1 is 2 divided by 1, 1 times 1 times 2 divided by 1. So this is 2, this is 2, and this is 1. All I did was treat each one of these like 1. So I assumed m was 1, g was 1, L was 1, and h was 1. Or just multiplied the coefficients to see what was happening. So now to rank these, we have C equals B, which is greater than A.